Hey, ladies and gentlemen, welcome back. Root Beer here, looking at the third question on our Ontario senior paper from 1968, way back when. A chord joins points A and B on the parabola y squared equals 4px. So this is a sideways facing parabola. That's kind of nifty. We don't talk about those a whole lot nowadays. If C is the midpoint of AB, and CD is drawn parallel to the axis of the parabola, so the dividing line, to meet the parabola at D, prove that the tangent at D is parallel to AB, the original line. Okay. I think I'm going to draw this just to understand sort of what's going on. Now, this parabola here, I'm just going to assume P is a positive value. If it were negative, it would just be facing the other way. But this parabola sort of opens up like this. That's not a bad sideways parabola, if I do say so myself. Then we've got point A here and say point B here. And then they're connecting them up. And we've got midway point, I'll say it's about here, C. And then parallel to the axis. Now, one of the nice things, and we should probably note this, the axis of y squared equals 4px is the x-axis. Okay? I would say it's clear. You can draw a picture, and that would be a good observation of it. Another way to see that is, well, the axis is what divides the parabola in half. So if I've got a solution here, xy, then I know y squared is equal to 4px. Can I think of another solution with that same x value? Absolutely, x minus y, because that will still solve this expression, because minus y squared and y squared are the same. So you can see the whole thing's sort of symmetric, same distance to the x-axis. So the whole parabola is symmetric about the x-axis. So there we go, but I don't think you need that much detail. I think you could probably just say, clearly the x-axis is the axis of this parabola. Okay, so if that's the case, what do? We draw the line through C that's parallel to the x-axis, and then it comes and it hits the parabola, they said, at D. And then they want the tangent of D, and they're saying that that's going to have to be parallel to AB. So I've sort of drawn my picture that way, but that's what we're looking at. Okay. Now, I know the coordinates of A. I know the coordinates of B. So I know the coordinates of C, because they said C is the midpoint. So let's say C has coordinates. To get the midpoint, you just average the x coordinates and the y coordinates. And those, respectively, give you the x and y coordinates for your midpoint. Now, CD is parallel to the x-axis. So D has the same y coordinate. So D is something, and then y1 plus y2 over 2. But D is on the parabola. So if you square the y-coordinate and divide by 4p, you get the x-coordinate. So square it, divide by 4p. Okay, I don't know what exactly p is, but that's okay. So now I sort of understand where D is. But they're asking me about the tangent line to the parabola. The tangent at D. So how do I make a tangent? Now, I could probably do a little bit of calc, because the tangent line is going to the slope of the tangent is going to be dy by dx. So that would be fine. But what else could we do? Let's phrase it this way. Suppose y equals mx plus b is a tangent to the parabola. Y squared equals 4px. Okay? So this is a nice little way to talk about tangent lines and almost any conic. So what we want is we want y equals mx plus b. If it's tangent to the parabola, then there's only one solution. There's only one point that they have in common. Okay, so what we can do, we can take this expression for y, plug it in here, and we will get a quadratic in x. And that would give you two possible x values, and that would be two possible points where this line hits this parabola. Right? But you're only supposed to have one solution, only one possible x point. And so we rearrange this, we'll get a nice little quadratic. M squared to the coefficient of x squared. 2bm minus 4p x plus b squared, and this is equal to 0. Now, I have no idea what p is, b is, m is, but we can use the quadratic formula. And so it'll be 4p minus 2bm. Yeah, switch that around. Plus or minus, and the square root. Now, this discriminant, the expression under the square root is going to be very important to us. So minus 4ac. Okay. But this has only one solution, which is what we want for a tangent line. If the discriminant, sometimes symbolized with a delta, I've seen textbooks use it with a capital D with that. That's fine too. But just this expression is equal to 0. So what do I need? I need 2bm minus 4p squared minus 4m squared b squared needs to be equal to 0. Otherwise, I don't have a tangent. So expand it out. 4b squared m squared minus 2 times 4 is 16 bmp plus 16p squared minus 4m squared b squared needs to be equal to 0. Well, I can get rid of those two quite quickly. Divide by 16 on both sides. Actually, you can divide by p on both sides. You'll get minus bm plus p is 0. So in order to have y equals mx plus b be tangent, we need p to be the product bm. So b times m needs to be equal to the p value that defines our parabola. Okay, so that's how you make a tangent line. Now we can talk about tangents without having to do any calculus. Although calculus is perfectly fine. I mean, this is a grade 13 level paper. At least grade 13 students were writing it back in the day, and they did know their calculus. Okay, but you know, this is just an interesting way to look at conic sections without having to resort to calculus, and I always think that's kind of nice. Okay, what were we trying to do? Trying to prove the tangent at D is parallel to AB. So, if y equals mx plus b is the tangent at D, not only does m times b have to be equal to p, but we know that D has to satisfy this expression. So the y-coordinate of D needs to be equal to m times the x-coordinate. We never actually did work out an x-coordinate for D. But m and p cancel out and leave a b here on the bottom. If I multiply both sides by 4b, I know the 2 and the 4 would cancel out a little bit. I think I'm happier leaving it like this. I can get 4b squared here. I can bring this over. We've got 0 is y1 plus y2 over 2 squared minus 4b y1 plus y2 over 2 plus 4b squared, and that is a perfect square. That's y1 plus y2 over 2 minus 2b. And this lets me figure out what b should be. And it also lets me then figure out the x-coordinate of d. So b needs to be equal to, let's bring the 2b over, divide by 2. So b is y1 plus y2 all over 4. Okay. So that's great. What I'd like to understand is m. M is the slope of the tangent line, and we're trying to show that it's parallel to AB. So we'd like to show that m is equal to the slope between A and B, which we actually haven't talked about. This slope here is, you just do rise over run. So I need to show m is this value. That's what we gotta go for. All right, so m is p over b. So 4p over y1 plus y2. And I don't really understand what p is yet. I know it's b times m, but we've just used that fact. So we use the fact that d is on this tangent line. And back here we use the fact that d is on the parabola. We actually haven't used the fact that a and b are on the parabola. A and b are on the parabola. So y1 squared is 4p x1. y2 squared is 4p x2. So there's 4p for both of them. Oh, if I subtract this equation from that, I'll get 4p x1 minus x2. So we got the makings, because this is difference of squares over here. So we've got the makings of the rise over run. So m 4p over x1, or y1 plus y2. But 4p is y1 squared minus y2 squared over x1 minus x2. And difference of squares, the top there. Bring this part down here. x1 minus x2, these cancel. And we're left with y1 minus y2. It's in a different order than I gave a moment ago, but they still mean the same thing. I mean, multiply top and bottom by -1 if you're really that fussy about it, but this is the slope of AB. So what have we shown? The tangent at D is parallel to AB. And that's exactly what we were asked to do for question 3 here. Okay, so a nice little way to approach the tangent there. Again, I said it already, you could do some calculus, I'm sure, to get the dy by dx tangent line, but I'm happy with what I did with the parabola there. Okay, up next is going to be question number 4. We'll take a look at that in the following video. Feel free to pause right now and try and do question 4 before I get to it.